Hey guys, very good afternoon everyone and welcome to another session of our domain analytics by 360DigiTMG. So we have been discussing about capital market analysis for the past few days and we discussed about various things like how to do the EDA. We discussed about applications of capital market, application of data science in the capital market, right? And we discussed about Chris Pamunkey working methodology as well. Today we are going to discuss about K nearest neighbor, what this is and how we are going to use this for our capital market analysis. So this is what we are going to discuss today. When we talk about K nearest neighbor, K nearest neighbor guys is one of the most simplest, famously it is called as Canon. So this is one of the most simplest machine learning algorithms that we are having in the supervised learning. KNN assumes a similarity between the new case data and available case and put the new cases into the category that is most similar to the available case. Canon algorithm also stores all the available data and classifies a new data point based on the similarity. This means when the new data will appear, it can be easily classified. It can be easily classified into a good suite category by using your Canon algorithm. When we talk about a KNN, it is also called as or regarded as a lazy learner. Because it, it does not learn from the training set immediately. Instead, it stores the data set and at the time of classification problem, it performs an action on that data set. KNN algorithm at the training stage just stores the data set, and when it gets new data, then it classifies that data into a category that is much similar to the new data. Suppose we are having a data set, or suppose we are having an image of, say, a creature, right? That looks very similar to, say, a cat and a dog. But we want to know either this creature is cat or a dog. So for this kind of identification, we can use a KNN algorithm. And this KNN model will find the similar features on the new data to data sets, to the cat and the dog's images. And based on the most similar feature, it will put it either in the category of your cat or your dog. Suppose we are having two categories, category A and category B. And we have a new data point, say x1. So this data point will lie in which of these categories? To solve this kind of problem, also we use a KNN. So while you are using the KNN, it will easily identify the category or the class of a particular data set. Another thing, the same thing is mentioned over here. Right? Another thing is, how do we, use your KNN? When we are dealing with the KNN, we have to select K of the neighbors upfront. Then you calculate a Euclidean distance on the k number of neighbors. Take the k nearest neighbor as per you have calculated using your Euclidean distance. And among these k neighbors, count the number of data points in each category. Assign the new data point so that the category for which the number of neighbor is maximum, and then your model is ready. Okay. So we understood that first we have to select your k value. But how to select the k value in the KNN algorithm? That is also a question. Before selecting, you have to remember some point. There is no particular way to determine the best value of k. So we need to try some values to find the best, best k value. The most preferred value for k is 5. This is the most preferred. A very low value for k, such as k is equal to 1 or 2. Now, if you select this value, then it can be too noisy. And it can lead to the effects of the outliers in the model. Larger values for k are always good, but it may be having some difficulties as well. When you talk about the advantages of your k nearest neighbor, it is very simple to implement. As I told you, this is one of the most simplest algorithm that we have. It is also very robust to the noisy training data set. And this can be very effective if the training data is very large. Talking about the disadvantages, it always needs to determine the value of k, which can be very complex sometimes. The computation cost is high because of the calculating the distance between the data points for all your training samples that you have. And this is how it works, as I was telling you. You have to initialize or define your k value, calculate the distances. You have Euclidean distance. You have Manhattan. You have Maganobel, right? And you have to find out the best distances, take the k nearest neighbor and apply this with the simple majority. And these are the advantages that we discuss. When we talk about, say, k nearest neighbor, as I was telling you that this is the simplest of the algorithms that we have in. And when you want to predict the class or the continuous value for the new data set, then most of the times your KNN is being preferred. Another thing that we need to understand about data preparation. The first thing under your data preparation for your KNN is first you have to do data scaling. To locate the data point into multi-dimensional feature space, it would be helpful if all the features are on the same space. Hence, normalization or standardization of the data will. Another thing is dimensionality reduction. Canon may not work, in a very better way if there are too many features. Hence, dimensionality reduction technique like feature selection or your PCA, all these things can be implemented. Another thing is your missing value treatment. If out of m features, one feature data is missing, for a particular example in the training set, then we cannot locate or calculate the distance from that point. Therefore, deleting that row or imputation is required. Talking about implementation of your Canon. Okay, even before doing that. So here we have the advantages. No training period. Canon is your lazy learner. It does not learn anything in the training period. It does not derive any discriminative functions from the training data. In other words, there is no training period for it. It stores the training dataset and learns from it only at the time of making real-time predictions. This makes the Canon algorithm much faster than other algorithms that require training. That is your SVM or linear regression, so on. Since the Canon algorithm requires no training before making predictions, so new data can be added seamlessly, which will not impact the accuracy of the algorithm. Canon is also very easy to implement, and there are only two parameters required to implement. That is the value of k and the distance function. There are some disadvantages also associated with your case. Talking about the disadvantages, your KNN does not work well with the large dataset, as calculating the distances between each data would be very costly. It does not work well with the high dimensionality, as this will complicate the distance calculating process to calculate the distance for each dimension. Canon is also sensitive to noisy and missing data. And feature scale means data in all the dimensions should be scaled, that is normalized or standardized. Talking about the implementation of your KNN in your Python. So first, what we need to do, we need to get and prepare the data. Another thing is, you find the value for k. You do the prediction. That when we talk about using your nearest neighbor for the capital market. There are various applications that one is while we are using your KNN, we can use it to forecast the stock market, to predict the price of a stock on the basis of company performance measures and economic data. We can also try to find out the currency exchange rate. We can also find out your bank bankruptcies. Besides this, we can also look into understanding and managing the financial year, trading futures, right? Credit rating, loan management, so on. One means n number of things you can do while using your payment for the capital market. So, in short, if I were to summarize, our KNN algorithm assumes that similar things exist in the close proximity. In other words, similar things are near to each other. Like, birds of a feather flock together, right? So, that is the principle on which it is. And there are, many ways of calculating the distance, but one way might be more preferable depending upon the problem that we are solving. However, the straight line that is called as the Euclidean distance is the most popular and the familiar choice that we use. KNN's disadvantage, guys, or the main, disadvantage, as I told you, that it is a lazy learner. So the Canon's main disadvantage of becoming significantly slower as the volume of the data increases makes it very impractical choice in the environments where prediction needs to be made more rapidly. Moreover, there are faster algorithms that can produce more accurate classification and regression results. However, if you are having sufficient computing resources to speedily handle the data that you are using to make the predictions, Canon can still be useful in problem solving that have solutions that depend on identifying similar objects. Okay. So now, if I were to summarize it on the whole, the k-nearest neighbor is a simple supervised machine learning algorithm that can be used to solve both classification and regression problems. It is very easy to implement and understand, but it has a major drawback of becoming significantly slow as the size of that data is in use is growing again and again. Canon works by finding the distances between a query and all the examples in the data, selecting the specified number of examples closest to the query, then votes for the most frequent label. In the case of classification, or averages the labels in the case of your regression. In the case of classification, when we talk about and or regression, we see that choosing the right K for our data is done by trying several K values and taking the one that is working with it. Right? So this was all about our KNN part. Now let me quickly show you the analysis that I have done using our KNN. The data set that I use is National Stock Exchange data set. I'm importing the required libraries over here, friend. I'm importing warning. I'm saying warnings.filter warnings ignore. I'm importing numpy and pandas, matplotlib. I'm also trying to import sklearn, Kernel classifier from sklearn neighbors. I'm importing accuracy score and I'm loading the list. Just a moment, guys. It is taking some time to load. I don't know. Okay, let me quickly restart my spider. Hmm. Okay. I don't know what is not showing over here. Let me run this. Okay. So these are the top 5 values that we are having. Top 5 observations which is being shown over here. And I am saying I want to check for all the missing values in this data set, and whenever I'm having the missing values, I'm just trying to draw. I'm taking the columns date, open, high, so on and so forth from the Infosys, storing it into a variable called as Infosys. And when I say Infosys.head, These are the various values that I'll be getting. Top 5 observations. And this is the, data set, by the way, that I'm using: open, high, low, close, so on. When I say Infosys.display, count means standard deviation is getting shown to me. Now I am trying to use a chart studio over here. And from the chart studio, I'm importing that as PY. When you talk about your chart studio, this package contains utilities for interfacing with Plotly's chart studio service. Prior to Plotly.py version 4, this functionality was included into your Plotly package as Plotly.plot. So this is basically having the utility for interfacing with your Plotly chart studio. If you face an error while importing this, first you need to pip install chart. Then from the plotly.graph underscore object, you are importing that as CO. You are importing plot from the plotly.offline as well. And various other things that I'm importing. That are the required libraries that Then I'm doing the plotting. The layout is equal to go layout, so on and so forth. Yes. I'm saying that x is equal to Infosys date y axis. This should be there. I store it into a variable called as Infosys underscore data. And plot, I'm saying go dot figure data is equal to Infosys underscore data layout should be there. So I plot, I'm saying plot. For the plot, I want the I plot. For this plot, I want the I. Initializing some parameters over here that Infosys open and close is nothing but Infosys close minus Infosys open. Infosys high low. Infosys missing value. On the x-axis, I'm taking your these things, various other parameters. So here, if you observe, you are getting the open close as 4. Highest is 9.5. Opening was minus 5 points. Same you are getting various. Now I am assigning the predictions over here. So I'm saying say y is equal to np dot weight Infosys close. See, the idea behind doing this is that we are trying to explore the data having details of the Infosys stock market. And this particular data set was containing your 1,227 rows and 7 columns. So first we started with importing the library. Data was having the column date, high, low, open, close, volume, ADJ flow. Then we imported the data display. And then we are trying to find the price according to the data. We are trying to find the price according to the data. So here I'm saying initializing some parameters. storing it into y, and when I say y, I'll be getting some prediction. We are assigning some predictions. The split percentage that I'm trying to take over here is 0.7% or 70%. And I'm saying use your split underscore percentage onto your Infosys dataset that you just opened over here, and the values that you get, store it into a variable for the training model for the X, training data for the Y, testing. I'm using the split for testing as well. And now I'm building your Canon model. I'm using your neighbors classifier, and I'm specifying your neighbors as 15 over here. The step that we discussed, that we have to first specify the key value. So here I'm taking your neighbors is equal to 50, and on this I'm using your KNN. The values that I'm getting, I'm storing it into as PS. Now this particular model is created, and now I'm running this model on my training data. I'm trying to find the accuracy for my training data, and I'm saying use your y_train as well as use your Canon and predict the value of the x of the trace. Find the accuracy score and store it into the variable for that accuracy underscore string. The same I'm doing for my testing data as well. And now I'm trying to print the testing and the training data activity. So for training data, I'm getting 0.63% of accuracy. And for the testing data, I'm getting 43% of. I'm using the predicted values that I'm getting from the S using your KNN and storing that into this data set new column for the predicted thing. I'm also taking a log of this Infosys and dividing it by a shift one. And the values that I'm getting, I'm storing it into Infosys is pi underscore data. I'm getting a cumulative underscore pi underscore data. I'm doing this for your strategy return. Now here I'm plotting the figure. And when we observe this figure, the observation that we are getting is that the accuracy of training model for Infosys stock market price prediction is about 63%. This is the kind of inferences that we are drawing on this. These are your spy returns, these are your strategies. We are taking the mean of it, predicting sharp ratio. So you have minus 0.92. I'm saying I want to use your KN. I'm running this model on the training database, saving the 10 to your model. Now I'm trying to find the probability, and I'm saying using the model that we just had over here, use it on your predict underscore probability on your testing data. The values that you get, store it into your variable called as probability. I'm trying to print the probability over here. So these are the various probabilities that you are getting for the values that you have in your data. I'm using your model.predict on your testing data. The values that I'm getting is stored into predicted value. And from the sklearn, now I'm importing your math. I'm trying to use your confusion matrix on the testing data and the predicted value. I'm also trying to use the classification underscore report on the testing data for Y and your predicted. So what it is going to do, it is going to build a text report showing the main classification matrix, that is true value, predicted value, all these. So here if you see, you have your confusion. And if you want to try to, if you want to find the true value, you have to take this value. Right? Now, I'm trying to find the accuracy of my model. I'm saying print model.accuracy on your training data. What we observe over here is the accuracy of our training model for the Infosys stock market price prediction is about 63%. So for this particular model, we are getting 63% of the accuracy. And this is, guys, how you perform your KNN on your this used example of your stock market, Infosys stock market that we were having. So the Canon algorithm will compete with the most accurate model because it makes highly accurate predictions. Therefore, you can use a Canon algorithm for applications that require high accuracy, but that do not require a human readable model. So the quality of the predictions depends upon the distance measured. Again, when should you use KNN? KNN is most useful when labeled data is too expensive or impossible to obtain, and it can achieve high accuracy in a wide variety of prediction type problems. KNN is a very simple algorithm based on the local minimum or the target function, which is used to learn an unknown function of the desired precision and accuracy. When we talk about using your KNN in the machine learning, the abbreviation for the KNN, again, it stands for K-nearest neighbor, and it is a supervised machine learning algorithm. The algorithm can be used to solve both classification and regression problems, and the number of nearest neighbors to know new unknown variable that has to be predicted or classified and is denoted by a K symbol. KNN is also known as your lazy algorithm, and the reason is that it does not train at all when you are supplying the data at the training time. All it is doing is it is storing the complete data set because it does not need to do any calculations at this point. Right? One more. The question comes that what is Canon? Is it a supervised or unsupervised algorithm? See, KNN algorithm is a simple supervised machine learning algorithm that can be used to solve both classification and regression problems. Is KNN same as clustering? See, the K in K means clustering has nothing to do with the K in the KNN algorithm. K means clustering is an unsupervised machine learning algorithm that is used for clustering purposes, whereas KNN is a supervised learning algorithm that is used for your classification problem. Is KNN or SVM, which one is better? When you talk about SVM takes care of the outliers better than your KNN. If training data is much larger than number of features, KNN is much better than your SVM. SVM outperforms your Canon when there are large features and lesser training data. SVM is less computationally demanding than your KNN and is easier to interpret, but can identify only a limited set of patterns. On the other hand, when you talk about KNN, it can find very complex patterns, but its output is more challenging to interpret. Right, guys? So guys, that was all about our KNN on this particular capital market analysis that we were seeing. I hope this session would have been very insightful to you. So thank you guys for joining. You people have been a wonderful audience, and keep on learning, keep on practicing. Be safe. See you guys tomorrow. Thank you so much.